Hello, I welcome you all to this another interesting screencast. In this particular video, we're going to solve the second and the third problem. We're just from solving the first problem. The second problem reads, if the resultant force acting on the bracket is to be directed along the positive u-axis and the magnitude of F1 is required to be minimum, determine the magnitude of the resultant force and F1, okay? In the second case, if the magnitude of the resultant force acting on the bracket is 600 newtons directed along the positive u-axis, determine the magnitude of F and this direction phi. All these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So here we are. There is this part here, minimum. What comes into your mind? Okay, minimum. Okay, so we need to have this optimized, right? Using derivatives and so on. Great. Great. So now what we need to do is I could use the x and y axis, but since I already know my resultant force says along the positive u axis, I can redraw this. I can change my axis so that I have, instead of yx, I can have uv. All right. Okay, so I'll have one axis, another one perpendicular to u. Let me call this one is perpendicular. So let me call this one as my v. Okay, axis v. Again, this is just one of the methods. Okay, you can go with the u, x, and the y. You still arrive at the same answer. Okay, great. So I'll need to find. So it means now our new axis is u and v. So I'll need to find this angle here, as well as the other ones are already there. So let's find this first. We find this. Sorry. Let's find this. Okay, so we can find this. You've seen this angle there. This angle there is as good as something like this. This is a 4, this is a 3, and this is a 5. Okay, right? Great. So let's find that angle. Let's find that angle. Great. So that angle there, let me call it alpha. I call it alpha. Well, I know already this angle there. This angle is just going to be equal to tan inverse of 3, okay, divided by 4. Remember, tangent opposite over adjacent. So this therefore gives us 3 divided by 4. Then tan inverse of that is a 36. So 36.87. So let me write it down here. I want to write it here. So this one is 36. So 36.87 degrees. Then we have now this angle here, this one here. Okay, so this one here we know it because this angle here is 45, right? This is 45. Therefore, we are just adding 36 plus 87. 45 plus 36.87. So this gives us 81.87, right? Is that okay? Great. Like I said, I've changed the axis. And then what else? In the rest of the angles, we know them. Then this one here is just going to be equal to, this one here is equal to 45 minus 5, right? Great. So let's draw now the components. So we expect component here, that is for F1 in that direction, like so. And then for f1, and then of course fy. So we have this, and then in fact for f1, where is f1? There we go. And then we're going to have another one in this direction. Okay, let me draw it somewhere, maybe down here, somewhere here, like so. This is f1. I draw it somewhere there, like so. Great. And then we're going to have a component for f2, like so. This is f2. Let me just clear this part here. That's f2. And then we'll have another component in this direction, like so. Sorry. Okay, like so. And then for f3 we only have one component in along the v. Okay, we don't have the component along the other side. Great. And then of course the resultant, we've already been told, is along the u-axis. So let's label this. So this is just going to be equal to f1 cos 45 minus 5. Okay, then this one will be f1 sine, this is sine 45 minus 5. Okay, and then we have this one, which is f2 cos 81.87, and then this one is f1 sine 81.87. Great. So again here, minimum, like we said, is about derivatives, but ideally we know when we have two vector forces, right? Let's say this is A and this is B, and we have the angle in between, and let's say A is our reference axis. That's where we want to map B. So we want to map B onto A. Okay, and then we are being asked to find the minimum value of B. Okay, what would be the minimum value of P? Only the axis C where A is. So we know that vector A dot vector B is equal to the magnitude of B, product of magnitude of B and A, then cos the angle. So when do you think we are going to have the minimum value of B? Of course, we know for us to have the minimum value of B, theta must be equal to what? Must be equal to what? Of course 90, so that this is equal to 0. So basically this is also what we're doing here. Alright, so we realize that the angle that we are going to find for f1 to be minimum about the axis u will be what? Will be 90 degrees. Okay, so there we go. Basically that is what we intend to do. So let's draw a table here. This table we're going to use it for both problems. I need black. Okay, something like this. There we go. So we have this one, 1, 2, 3. How many are there? There are 3. Do 3 and the resultant. Alright. And then we have the ones we are dealing with, like so. Great. So there we go. So this is going to be F. And then we have U. The units are newtons. Then we have V. The units are newtons. Then we have F1, F2, F3 and the resultant. So let's write down. So what is F1? F1, have we been given? Alright, so there we go. That's what we are looking for. We'll have a positive value along the u-axis, so we'll call it F1 cos 45 minus 5. Okay, and then F2, I mean the y component will be negative F1 sine 45 minus 5. Then F2 along the u-axis, this is a 650 cos 81.87. Then the other one is a positive 650 sine 81.87. And then F3 just have a negative along that direction, which is just 500. Negative along the u-axis it is 0, and along the v-axis is negative 500. Alright, so then we sum up this. My space isn't much in here, so instead of writing in this table, I'm just going to write down here. I'll have FRU. Now when we are used to x, FRU, FRV. So I'll have FRU is equal to, that's 650 cos 81.87. Okay, so this gives me F1 cos 45 minus 5 plus 91.92. Okay, that's 650, that's 35, 36.87. Okay, 81, 87. Alright, by 650, this gives us 91.92. Great. And then FRV, what do we have there? We have a 650 sine 81.87 minus 500. So this gives us a minus F1 sine 45 minus 5. Okay, and then plus 143.47. Okay, 650 sine 81.87 minus 500. That's 143.47. Great. So there we are. We have these components. So now let's go to case 2. Case 2, which is 2-45. Great. Okay. So the resultant is already given. The resultant we've been told is along the u-axis. So we know from here that we know what this is. FRV is going to be equal to 0 newtons, right? So along the V is 0 because the resultant is along the u-axis, positive u-axis. Okay, so with this in mind, we know that we can just write down the equation. Let me borrow one equation here. I'll borrow this one with a 0. Okay, I bring it here. Right. Since we know that FRV is equal to 0, I can just write this and say my F1 therefore is just going to be equal to 143.47 divided by sine 45 minus 5. So I'll need to find the first derivative of this. So I'll say, so that I find the minimum, I find the angle that will give us a minimum value of F1. So dF1, the phi is going to be equal to, so we are using the quotient rule. So we have a 0 sine 45 minus phi minus 143.47, and then we sine, the derivative of sine is cos. So we have cos 45 minus phi, and then since this is here, we need to use chain rule when finding the derivative of sine 45 minus phi. So derivative of sine is cos 45 minus phi, and then the derivative of 45 minus phi is just a minus 1, right? Then everything divided by sine squared. Remember the quotient rule, right? Okay, then this will equate it equal to 0. Okay, so if we are to work out this, of course this part goes to 0, this is 0, minus and minus becomes plus. So when this component just becomes 0, then the equation will be satisfied. Therefore, what you're interested in right now is cos 45 minus phi equal to 0. And we know to say one of the solutions here is 45 minus phi is equal to 90. Okay, and therefore phi is just going to be equal to minus 45 degrees. Okay, right. So therefore we want to find the magnitudes of the resultant force and F. All right, so let's work it out. Let me just I need some space. So now we found phi, so it means we can find what F1 is. So F1 is just going to be equal to, so we use this equation here. Okay, so when you plug in phi there minus, it becomes sine 90. Therefore our F1 is just going to be equal to 143.47 newtons, right? If we plug in here, if we plug in minus sine 45, then we'll have the sine 90, and sine 90 is equal to 1. So this is the minimum value of F1. Okay, so we have F1. So we need to find these components. FRU, we already have FRV. So our FRU therefore is just going to be equal to, we plug in what F1 is, we have this equation already, this one here. Okay, so let's plug in F1 and the rest of the values and phi. We know that phi, we already calculated what phi is. We know that phi is equal to minus 45 and F1 is equal to that. Therefore our FRU is just going to be equal to, our FRU is equal to that's 143.47 cos that is cos 90. That part becomes a 0, right? That part becomes a 0. Therefore, FRU is just going to be equal to 91.92. And we know that FRV is just equal to 0. Okay. FRV is equal to 0 newtons. Okay, and using the Pythagoras theorem, we know that the resultant, we already know it is 91, but this is how we work it out, right? Squared plus FRV squared. Therefore, our FRU, once we plug in those values there, it gives us a 91.92 newtons. Right. So I think we are done with our first problem. Let me just create a small boundary there. We are done with our first problem. There we go, something like that. Great. Then in the second case, which is case, so we are now case 3, which is a 2-46. Alright, what have we been asked here to find? Here we've been told that the magnitude and the resultant force acting on the bracket is 600 and is directed along the positive axis, and we have been asked to determine F and this magnitude. Okay, we have been asked to determine F and this magnitude phi. Alright, so this one should be F1, right? This one should be F1, right? F1. Okay, so that is F1. All right, so we want to find F1 and phi. This is what we want to find. Okay, and phi. So now we know here that FRI itself is equal to 600 newtons. It's directed along the u-axis. Okay, and from this information, since it's along the u-axis, we therefore know that the components of FRU is going to be equal to 600 newtons, and FRV again will be equal to 0 newtons. So since we want F1, we can plug this information, and phi, we can plug this information in here, and then we work out this particular problem. Right. So to do so, let me write here. To do so, we are going to do the following. We have Fu, so we'll have an equation. 600 is going to be equal to F1 cos 45 minus phi plus 9.91.92, and then the other one is 0 is equal to minus F1 sine 45 minus phi plus 143.47. So working out this, you can divide the two, then we are going to have tan 45 minus phi is equal to 143.47 divided by 600, okay, divided by, what is happening? divided by 600 minus 91.92. Therefore, working out this, we are going to have phi, of course, we are going to have 45 minus phi equal to, so grab your calculator and work out this. Grab your calculator. So we have 143.47 divided by 600 minus 91.92. Then tan inverse of that, we have a 15.7684. Therefore, phi is just going to be equal to, phi will be equal to, and this sums up with, so phi will be equal to 29.23 degrees. Okay, so 143.47 divided by 600 minus 91.92, and then tan inverse of that. Okay, and then we throw it to the other side there, and then we have a 29.23. So we have this. Let's now use this equation here. We know that F1, okay, using this equation here, okay, we know that F1 is just equal to 143.47 divided by sine 45 minus 5. Once we plug in phi in there, we already found what phi is 29.23. So we'll say 45 minus, we'll say sine 45 minus 29.23. Okay, and then 143.47 divided by answer. F1, we get 527.90. Okay, and we round off that newtons. Let me just check it out again. 143.47 divided by sine 45 minus 29.23. 527 point, of course, round off 90. Great. So we found F1, we found phi. So let's just outline our solutions. So in the first case, we have been asked to determine the magnitude of the resultant as well as F1, right? So we found F1 here, okay, which was the minimum value, okay, and we also found the resultant. All right. In the second case, we have been asked to find phi and F1. So this is our phi, okay, and then this is our F1. The question must have read F1, not just F. Okay, I think this is about it. This is really about it. Again, this is another way of just solving it by changing the axis, but you can still work it out using the normal axis, the U, X, and Y. All right. I hope the video was helpful, and if it was, give me a thumbs up. I like my video. Continue subscribing and liking my channel. Bye bye, and see you in my next screencast.